Welcome to Max-Men's Applied Electronics example number 2. All right, here's our problem. The charge transmitted through a circuit varies according to Q equals T raised to the 4th power minus 4 times T raised to the 3rd power coulombs. Find the time in seconds when the current I in amps, I equaling dq dt, reaches a minimum. Okay, so we're trying to find a time in seconds when I is at a minimum. And we're given Q, the formula for Q, and we're given a formula for I. And so because I is equal to dq dt, let's go ahead and take the derivative of Q, and then we can substitute that in and now solve for I. And now we've got I in terms of T, so we're looking good. The question is find the time in seconds when the current is at the minimum. And so what we want, we've got our I in terms of time. So we're looking for time and we're looking for current at a minimum. So now we're going to take another derivative. We're going to take the derivative of the I, and then in terms of T. And then set that to 0 because we know that should be our minimum when our slope is equal to 0. And now we can use you can use quadratic formula, or you can use your TI-89, and you should get two answers for x, a 0 or a 2. And 0 is not really time, it's nothing. And so our answer should be 2 seconds. And if we put our original function into Desmos, we can see we've got the red line represents the equation for I. And now if we take the 2 seconds and put that into the equation, we can solve for an I equal to minus 16 amps. And so if we make the x-axis is our time and our y-axis is our amps, we can see at 2, x equals 2, or time equals 2 seconds, we do in fact get a minus 16 for our minimum, minus 16 amps. So you could think of this also as the maximum in the negative direction. So sometimes you can think of the minimum as the maximum in the negative direction.